Okay, guys, so welcome to your SAT Bootcamp. This is our first recorded video, and we're going to be picking up where we left off, and it's going to be the same format where we do a chapter a week, and I'll post some questions online. Kind of what I want to do is do a few examples with you guys, and hopefully you guys are following along and you pause the video and attempt to solve it, and then come back and check your work, and then I'll give you practice problems that are similar to the examples we did, which is slight alterations, so you guys are ready to go, at least for that topic for the SAT. So let's just hop into it. Today, what we're going to be doing is functions, right? Okay, so for functions, we've seen functions are basically our entire life, right? As at least up until middle school, where we have something that looks like this, right? F of x squared, f of x equals x squared, right? And kind of we ask ourselves, what's the idea behind the function, right? So you have your inputs, right? Then you have your outputs. And this is f of x, or this is y, right? So for our function here, we have f of x equals x squared. You can have 1, 2, 3, 4. What would our outputs be? Well, it would just be whatever the rule says. So it would be 1 squared, 2 squared, 3 squared, 4 squared. Right? We're just substituting these values in here for x. So you get 1, 4, 9, 16. And if you guys remember this, if we remember that we have inputs for a function, and then we get our outputs, which our outputs can be denoted as f of x or y, then you'll be able to solve virtually all the function problems that will be thrown at you on the SAT. So let's go into an example. So let's say we have f of x equals x plus 1 raised to the x, right? Find this value, right? So we have our function here. Find the value f of 0, f of 1, f of 2, f of 3. Attempt to solve that, guys, so pause the video and come back and see if you got it right. So, okay. So, let's see. So we have our function here, and just like our inputs, right? Our inputs are going to be, what are our inputs going to be? Our inputs, x, will be 0, 1, 2, and 3, right? And what are our f of x? Well, let's see. For 0, we'll do 0 plus 1 raised to the x. So, this is 0. And this is actually not the best color. I'm not going to use this again. Right? Then you have 1 plus 1 raised to the 1. You have 2 plus 1 raised to the 2. 3 plus 1 raised to the 3. Right? Now you may ask yourself, why are we doing it like this? That's because we have right here, this placeholder here, right? These values here and these values here. That's just where x is. Right? These are where the x values are. So we're just subbing them in. So now from here what we're going to do is we'll just evaluate. We'll get 1 to the 0, 2 to the 1, 3 squared, and 4 cubed. Right, so anything to the 0 of course is 1, this is just 2, this is 9. This is 4 cubed, which is, remember, the same way as doing this. 4 times 4 is what? 16 times 4, right? This becomes 16, 64. So now what we do is we add them all up. Right? The original problem said add up all these values, so you were going to get 1 plus 2 plus 9 plus 64. Right? So that's 10 plus 2 plus 64. It's 12 plus 64 for a grand total of 76. So hopefully you guys got that. And if not, you just remember the take-home thing was we want to plug in our x values. Whatever we're plugging in for inputs, we just put it in where our x values are for the output. So our input here was 0, we'll plug in a 0 here and a 0 here because there's an x there and there. Okay, so let's look at this example here. Can I clear this more? Yes, I want a blank space. Okay, let's do a different color. Wow, so many options. Green. Just go back to green. Okay, so let's say we're given f of x equals 4 over x squared minus 10x plus 25. Right, so find value of x where f of x is undefined. Alright, so attempt to solve that, and we'll come back to it. Okay, so hopefully you guys had a successful solve. The key word, of course, is this, where we're looking for something that is undefined. And when a function is undefined, we know undefined can be like plugging in a negative number for a square root, right? So plugging in, right? So this is your function, and you plug in -2 for x, and you get f of -2, you'll get, right, most of the time this will not be defined, unless you're dealing with imaginary numbers, and in that case, it would be defined, right? But most of the time we're dealing with real value functions, or real numbers that we're used to dealing with. So in this case, this is a function here that's going to be on the real numbers, and when it's undefined for real numbers, usually it's whenever you're dividing by, like if you're dividing by 0. That's never good. So what number can we plug in for x that will give us 0 here on the bottom? That's another way of kind of attempting or thinking about this problem. Well, the key to this is recognizing, either you can see it off the bat, or recognizing that this factors out into x minus 5 squared, where x squared minus 10x plus 25 equals x minus 5 right? So this is, I think, if I remember the term, product of squares. This is just a common way to factor out when you have a negative here in front and then you have a square here, right? Because 25, of course, is 5 squared. So we can rewrite the function as this, and clearly we can see we plug in 5, you'll get 4 over 5 minus 5 squared. 4 over 0 squared equals 4 over 0, which makes that function undefined. So the take home was to make sure we can factor this, replace it with x minus 5 squared, get our new function here in our box, and then realize plugging in 5 here for the bottom will make that 0. Okay, so let's go on. I'm still trying to see what. So these are all the same colors, but okay. Let's see, we have f of x minus 1 equals 6x, right? And g equals x plus 3. Find f of g of 2. Find this. Okay, so similarly to like last time, pause the video, attempt to solve it, and click back when you think you have a solution. Okay, so hopefully you guys had a good chance at solving this problem and it was successful. So we're looking at a composition of functions, right? So you're looking at f of g of 2. And if you guys remember with composition of functions, you always want to work on the inside. So you always want to work on the inside. So the inside here is g of 2, right? What does that equal? Well, we know what g of x equals, right? So g of 2 is just going to be plugging in 2 for x, which is 5, right? So we know g of 2 equals 5. So if g of 2 equals 5, then we can, instead of doing f of g of 2, I can just say f of 5, right? Because that's the same as f of g of 2. And again, because you have g of 2 here equal to 5. So we're just subbing out g of 2 for 5. So we can make this an equivalent statement. So now to find f of 5, right, that's the next step. Well, we know what f of x minus 1 is. F of x minus 1 gives you 6x. So this is a little bit different than just your normal f of x or g of x function. Right? You have x minus 1. So you're looking for a number x that will give you 5 here on the inside. Right? Well, of course, 6 minus 1 gives us 5. So if x is 6, then f of 6 minus 1 equals f of 5. But what does our rule say? Our rule says if you plug in x here, whatever x you plug in here, I have to plug it in there. So that would be 6 times 6, right? That's your x. I'll do it here in green. This is our x here, and this is our x here. That's what our rule says. Our rule says whatever you do for x, you must multiply by 6. So since 6 is the one that will give us, 6 is the x that will give us f of 5 here, we know f of 5 is the same thing as doing 6 times 6, or 36. So this should have been the answer you guys get. Usually you won't get composition of function questions this difficult. But let's try another one. Okay. Okay, we'll try this one. Let's say if you're given a function here, y equals ax squared plus 3, and this function crosses the point 1, 2, right? Find value of a. What's a, right? Okay, so attempt to solve this problem and then pause it and come back and see if you got it. Okay, hopefully you guys had a good go at this, and this is just making sure we got it right in case you didn't. Let's see, so we have this function here, y equals ax squared plus 3, right? We don't know what a is, that's the point of solving a problem, but we do know that this function, right, it hits this point here, 1, 2, right? So let's say we have our point here, 1, 1, 2, right? Let me see this real quick. I don't know if this function looks like this. Who knows? All we know is that it hits this point right there. It hits that point. Okay, so if it hits that point 1, 2, right? What does that mean? Well, that means that the input, when I plug in my input here, x for input, and then y, right? If I plug in 1, I get 2 out. So that means I can plug in 2 for y, and you do a times 1 squared plus 3, right? Because that's just my x. All it's saying is that this is a true statement. I plug in a 1 for my x and I get a 2 out. That's the point 1, 2. Okay, so let's solve this. So 2 equals a plus 3. So we just take away our 3s, so you get minus 1 equals a, right? So a should have been negative 1. You guys got that? That's awesome. And this section will be a breeze for you in the SAT. Okay, let's try another one. So let y equal x squared plus 2x minus 4, and y has the point m, 2m with m greater than 0. Find value of m. Okay, so we have y equals x squared plus 2x minus 4. Okay, of course, pause the video and then come back. Okay, so hopefully you guys paused it and you now you're back to make sure to see if this is right. So you have this function here, y equals x squared plus 2x minus 4, right? And you know that what's your input? Your input is m, and your output is 2m, right? X and y. We don't know what these numbers are, we just know that this is true, and m is greater than 0. So this number here must be greater than 0. So let's just plug in what we have. So we have 2m for y. Let me do a different color. That looks too much like the writing problem. No. We have 2m for y equals m squared plus 2m minus 4, right? Because I'm just plugging in these m's for x. These are my x, and this is my y, right? So now we solve this. So we bring this equation down, right? I'll get these cancel out, right? Take away 2m, so now you're left with 0 equals m squared minus 4. Add 4 to both sides, so you'll get 4 equals m squared, right? So now remember we just solve it, right? So you do your square root, plus minus, square root. You'll get plus or minus 2 equals m. But remember, what does the problem say? The problem says, well, m is greater than 0. So if m is greater than 0, then m must be positive 2, right? And a way to check this is you can plug in m equals 2 to y equals x squared plus 2x minus 4, and you'll get 2m or 4, right? Because again, m equals 2. So 2 times m equals 2 times 2 equals 4. Okay, let's see. Let's do a few more, and I want to give you guys some good practice. Let me see if there's a good one here. Oh, this looks good. Well, yeah, this looks good. Okay, so you have, let's say we have this function here, our x and y points here, right? And you have 0, 1, 3, 20, 21, 29, right? Which of the following here could be x of x? So which function, which choice of f of x? So you have f of x equals 20x right, so one of these here, A, B, or C, well, when you plug in x, your x values, you'll get your y values. So figure out which one that is, and then come back. Okay, so hopefully you guys had a good go. Let's see. So we're looking for which one of this table here is some function. It's some f of x. We're looking for, is it A, B, C, or D? Well, let's just go through the first one, right? So let's look at A. So A says 20x. So if this is a function, then when I plug in 0, I should get 20, right? Well, if I plug in 0 here, I'll just get 0. So A can't be right. And we'll do the same thing with B. I plug in 0, I get 20. Plug in 0, sure enough, I do get 20, right? Well, and it's good. So far, we're good. If I plug in 1, and I get 21, right? Because 1 plus 20 is 21. But if I plug in 3, I get 23. Right, so that's not 29, so it doesn't work. Let's look at this one, right? So this is x minus 20. So if I plug in 0, I should get 20. Well, if I plug in 0, I'll get 0 minus 20, or negative 20. So automatically that can't work. So we're done here, right? So we know it's D, but just to make sure we did our math right, 0 squared is 0 plus 20, so we'll get 20. That's good. Let's see, plug in 1. 1 squared plus 20 is 21. That's also good. 3 squared plus 20 is 9, so our 9 plus 20 is 29. Sure enough, that gives us our answer. So the answer was D. So this is just a way of looking at the table of the function, the inputs and the outputs, matching them up. You want to just try to prove one can't be right? Because like for example, this one had them all, B had them all, except when x was 3. So it's very close. Okay, so let's look at, can I move that up? No. Let's look at, we'll look at one more, and then I'm going to post some more questions, and you guys can attempt to solve these, and then I'll post a solution for all the ones that I assigned. So, okay, can I do a straight line here? No. Here we go. Okay. So let's say we're given this graph here, and the graph of the blue is, I'll do it in its own color, right? This is y equals 9 minus x squared, right? So, and this right here is, this is point A and this is point B. Find the length of AB, or basically this line right here. This is a right triangle, so you're looking for the hypotenuse, and that's kind of a clue on what you need to do. So pause the video, of course, and attempt to solve it, and then we'll pick up where you left off. Okay, so hopefully you had a good solve, and let's see how this works. So, right, so this point is what? We know this is the origin, or 0, 0, right? So let's plug in, if we plug in a 0 here, it'll give me this point, it'll give me this height, all this length right here, right? So if I plug in 0, I'll get 9. Right, because 9 minus 0 squared, so this length is here is 9. So now I have one side of the triangle, because the goal here, since it's a right triangle, is to use a squared plus b squared equals c squared, right? So we have our a. Now let's look for our length of b. Looking for this length right here. How can we get this length? Well, this length is whatever x value, this is some x, but we know the y value is 0, right? So we're looking basically for when this value here is 0. So I can solve that by setting that equal to 0, saying 9 minus x squared, because that'll give me this x value when I solve for this x. So then I'll just rearrange it. X squared equals 9, x equals plus or minus 3. Since we're on the right side and we're looking for a length, we can eliminate the negative, right? So we know we're just looking for plus 3 or 3. So this length here is 3, right? So I have my a and my b, so we can use this. So we can say 9 squared plus 3 squared equals c squared, or 81 plus 9 equals c squared, right? What is that? That's 90 equals c squared. So if I take the square root of both sides, I'll get square root of 90 equals c. So now this, we break it up in terms of radicals, so we'll say square root of 10 times 9 equals c, that's just 90 here in the bottom. This is just a property of radicals. We can go over, I could do a video on this if we need to. This is going to be 3 times square root of 10 equals c. So that's essentially what this length is here. So what you should have got for AB is 3 times the square root of 10. So if you got that, you guys are good. That was a harder problem, I think, than we're used to solving. So let me see. I just want to say any more that I want to do really quick. I don't think so. No. Okay. So I'll post the rest, and then tune in next week, and then of course email me if you guys have any more topics we want to look at, or different topics, because I think next week we're going to be doing either lines or angles, something like that. Maybe linear models, I'm not sure. But anyway, okay, good luck guys, and stay safe, and ready to get back into school, I hope. Okay, talk to you guys later.